So welcome to week 12 of Python. Congratulations, we're almost toward the end of the entire syllabus. We have made a lot of progress so far. We've learned how to work with basic Python syntax, how to work with Python, how to work with pandas, and doing things like data visualizations, data cleaning, and so on and so forth. So this week we're taking all of the previous works a little bit further and trying to build something that people can actually use, or you can actually use from all the visualization, data cleaning, and so on and so forth. So feel free to let me know, well, if you can hear. Before that, is my voice all sounds good? Screen sharing is good? Okay, I see a thumbs up. All right, so today we're going to use another data set from Kaggle. You should be able to just run this script and download it depending on your local directory. You should just copy this thing from the path or just go to this Kaggle website and download the data set. So this CSV is for the car sales data for BMW from year 2014 to 2024. We have 50,000 data points from this. You can know, okay, what is transmission, fuel type, color, and so on and so forth. I'm only using a fraction of this data set. There's a lot more interesting thing you could do from this. For example, you could try to run an analytics and see, oh, which one is the best performing car? Which one is the worst performing car? Is there any specific trends in North American markets, Asian market, Middle East market? Is there any trends particular in hybrid model, diesel model, petrol model, something like that? I'm only using a fraction of that. Feel free to explore that if you're interested in working on it. And I think it's a pretty clean data set. I don't see any missing values, and all of them seems to be in the right data type, so I didn't do much of the cleaning, which is rarely happening in real life. So this is how the data set approximately looks like. Okay, now I want to do a quick analysis and visualization on this. What I really want to do is to plot the most popular model by year. I should probably say 3 most popular model by year. So I just want to know the most popular model in year 2014, second most popular model in year 2014, and the third most popular model in that same year. And which of that actually does the job if I want something like this? So I'm kind of breaking it down into 2 operations. The first one is going to group it by year, model, and count. How many sales exist? How many times this model is sold? For example, in year 2010, the Model 3 series is sold 317 times, and so on and so forth. And of course, this is for all of the year, right? For year 2010, I'm only plotting out the first 5 records. There are probably hundreds of different cars selling at different year. So I'm just curious to know what's the 3 most popular one, like the following. Which of the command above actually does it? And to just save your time a little bit, the second line is always the same. The only difference is in the first line. So there's difference of, okay, I am resetting the index or no. What's the difference between that? And the second thing is, okay, if I am grouping by year versus grouping by year and model, what's the difference between that? So I'll pause a few seconds to let you guys think which one is the right answer to do this operation if I want to ultimately get this thing. Feel free to type your answers in the chat. Pausing for a few seconds to let you guys think about it. Anyone? And guess? If I only group by year, ultimately I will try, that would mean I'm collapsing all the records to one single year. So do I get a lot of records for year 2010? Or do I only get one record for year 2010? Okay, what if I'm grouping it by year and model? What does it actually do? And what does reset index actually do? That's a common question that appears in our day-to-day life. Anyone?
So I think if you group by the
Sorry, can you say that
uh
again?
yeah, so I was thinking if you group by the year and model, it will only just show the like the total of groups in one group, how many of that group are in the same in that table, and also the year.
Correct. If you only group by year, then instead of 2010 and 3 series, you won't have the model at the end. You will have all of these things sums up. So we could actually just quickly run through this and check. Why is it popping up? Why is it? If you only do this, this is all you get. You're basically only getting 1 year and total counts of that instead of having the year and model. Okay, so it seems like we need to group it by year and model, right? So what happened when we do that? Thumbs up if you think this is the correct operation. We don't need to reset index at all. Or type a +1 in the chat if you think this is correct. Okay. No one? All right. You'll get an error because let's see what's happening with df of years. If I run this and just display it, you'll see why this grouping by isn't working. Notice that when you're doing group by with two different stuff, you're creating a multi-level indexing. What does it mean is that, okay, you have the first top level index, which is the year, because you first group it by year, and the second is by model. You do get a count as we intended, but this is a nested indexing, which is not an ideal way to present this type of data for various reasons. It could be something you want to use in a spreadsheet or in the final presentation table. We see this type of reports all the time. This is the year, this is maybe like different breakdown of the cells and so on and so forth. But this is not something that is very healthy programmatically because multi-indexing has a very weird indexing pandas, in my personal opinion. And as you can see, when we're doing multi-indexing, a lot of the operations is kind of failing. It doesn't mean that you couldn't always do multi-indexing, but I would advise against it. So here we do get the data we want. The problem is it's not like a very healthy way of aggregating the data. It's year 2000, 2010 and something so on and so forth. And when you're selecting the data, you need to do a different syntax. If you remember, for those lock with multi-indexing, you'll need to do something like this and so on. Well, this is iLock because it's indexing at year 2010 and something like 3 series, something like this. This is the time you will need to do iLock like this. This model and year, they're no longer the columns, they're the index. This could be problematic, could be helpful, depending on your purpose. But it's not the right operations. So for this particular case, what we're interested in doing is, well, we're also trying to store them by year and so on. So only selecting the top 3 model. And the easier way to do it is just by, well, first flatten it, create a new column, and deleting this. Now I can show this. And now I have a more normal data frame that I'm usually working with. This is kind of a common operation, not just in pandas, but also in SQL. You could also think about how could you do this in SQL. That's a good exercise to make sure you're familiarizing yourself with both pandas and SQL. Okay, cool. So now I have these data set. I know what is the top 3 model for each year, and that's what's left in the DF top 3 data frame. Great. Now I want to visualize this, and here I'm using a matplotlib library to plot it. I mean, I tried another seaborn built-in plot, but it's not ideal. So ultimately, I decided to go with the matplotlib, kind of a customized plot for matplotlib. So here I'm seeing, okay, this data set is showing me some trends over the year. The top 3 selling model data seems to be relatively different, like 3 different models. Okay, some of them changed in popularity and so on and so forth. But ultimately, it seems like the sales of top 3 models were displaying some trends. And yeah, that could have some seasonality. That could be due to like global economic crisis or so on and so forth. You could also change the way you're trying to plot this data. Okay, great. But what if I don't think this is interesting enough? What if I want to select more different items into the plots, right? This plot is like every single time I have to run it, maybe I can wrap it into a function and do it kind of automatically, but is there a smarter way for me to do more with the same plots? The answer is yes. There's a lot of interactive plotting things we could do in Python. The first one we're going to introduce is Plotly. It's another visualization platform, but it's supporting basically an HTML rendering instead of like static rendering. What does it mean is that, okay, the plots you created with Plotly, like this example taken directly from this week's material, is interactive. Okay, so the way to make sure it's interactive depends on which file format we're using. What Plotly is doing is that, okay, when we're calling this function, it's creating an HTML object embedded directly inside this page. So now, because it's an HTML, you could just interact with it just like interacting with the web. You could select the range of the data, zoom in, zoom out. Okay, I'm selecting this range and it's getting out of range. Ouch, clicking on the wrong thing. Auto scale back, I could select and zoom in to just take a look at this data. I was selecting the right thing. And then pan something, lasso select. I could select data from this range and export it, copy paste it, whatever you like. So now you have a lot more interactive options with it. I can keep zooming in, zooming in, zooming in, zooming in, zooming out, zooming out, zooming out, zooming out. There's a couple different things you could do with it. So let's try to run this in our data thread. So notice that these things requires your data to be numeric, kind of, or at least with some label. So you do need to make sure your data type is right. If you're trying to plot a categorical variable into a scatter plot, you'll get a very weird result, just like what we have seen last year. So here I have created another function. It's basically trying to create either a 2D plot or a 3D plot based on all the numeric columns in my data frame. Okay. So now I'm just looping through that and make sure I can I'm checking, okay, are they numeric? If they're not numeric, for example, how am I supposed to plot a scatter plot for 5 series? Where's 5 series supposed to sit? Here, 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 I don't know. Technically speaking, you could with something called label encoding, but that is not a good solution for scatterplot. In general, scatterplot only works for continuous or semi-continuous variable. It's not working for like categorical variable. Categorical variables are great for labeling, but not for scatterplot. So here I'm only selecting basically these 4 plus the year. These 5 columns, they're numerical, and they would allow me to do a scatterplot. Of course, there's more than a scatterplot in Plotly. Feel free to dive into their APIs, ask ChatGPT, ask whatever AI you're using, but make sure you know what you're doing. One example is that all 3 of this version a lot of these versions could work. ChatGPT could generate a lot of these same codes, but it's probably not what you're expecting them to do. For example, I could run this perfectly by swapping model and year. This code will work perfectly. I could just show you now. First by model and then by year. It's capitalized. I could show you the same thing, but the result is almost the same, right? Well, not exactly if you group it. It's not always the same. Well, in this case, it's actually not the same, and it's difficult to spot it. If we forget what's the previous result. I think the top 3 things weren't the same, but anyway. These 2 things could work basically, well, in this particular case, it's very difficult to spot the errors. I'm pretty sure they're not exactly the same if you group it first by model and then by year, versus by year first and then by model. There are a couple cases when this aggregation order matters a lot. And so does the sorting orders and so on and so forth. So you do need to make sure you know what your code is executing. And the same goes for plotting. A lot of the plot could work, but it could make nonsense. For example, this thing, I'm just trying to run this plot. Is this a good plot? It seems like I'm plotting like 50,000 points in this 3D scatter plot. It's still interactive. It's kind of what I want to do. I'm trying to see if there's any relationship between any patterns I can observe in price USD, in the mileage, and the engine size. But can I actually see anything from this? Well, no, because I have way too many plots. So let's restrict the range a little bit. What did I do? Oh. Let's restrict the range a little bit so that we can see the patterns. Patterns slightly better. Hold on a sec. Wait. This one. Now it looks slightly better, even though there's not much patterns to observe. So that's okay because, well, there's a lot of different combinations I could try, right? I could try engine size versus mileage and just do a 2D plot and see what do we have. Engine size L. Okay, maybe there is some pattern. I might want to do some statistical analysis onto it. Maybe, maybe not. Or let me try to change it into 200 points. Or maybe the pattern exists for other vehicles. Let's see. Okay, and so on and so forth. This could go infinitely. But this is kind of a tedious process, right? I'm switching around a lot of times and like there are so many different columns, and in real life, you may have like hundreds of things you could visualize like this. Is there a better way for us to run this process and see if there's any pattern? The answer is yes, and that is what we call dashboarding. So dashboarding is basically a process by creating the plots with the functions that allows the user to kind of just work with it like dashboards in real life. Basically, you're creating a dashboard, and the dashboard is basically, okay, some data visualization tool you can work with to interact with the data so that you can see things happening. And the most common tools to build them are Dash and Streamlit. And today I'm only doing a demo with Dash, but the logic is very similar with Streamlit. So both, let's kind of have a quick overview of them. So there are powerful ways to kind of, okay, what if I want to build this thing with more options on the website? What if I want my website to have something like this? And I want my user to be able to interact with this. Not necessarily in a Jupyter notebook, but somewhere like opening a page. Can I do that? Well, if you're a if you're a full stack developer or front-end developer, maybe it's just, okay, I'm going to write a few lines or a few hundred lines of React code, creating a database and a Node.js, something, and create a full stack app for that. But that seems like an overshoot. So Dash and Streamlit are basically platforms that are trying to say, okay, you don't really need to build a full website if you want to show your users on the internet. You could build something like this. If you have a great, simple application that you want to show to the users on the internet, Dash and Streamlit just say, okay, you could just write a Python file and they'll handle the rest for you. You don't need to create a front end like JavaScript or React directory, a backend like Python Flask directory handling all the APIs. You don't need to create an SQLite or whatever DB system you're using to host a website. They will simplify the process. All you need is a Python file. And you can create plots, Python scripts, or everything else you want to do within the Python file you are working with. That sounds great. And what's even better is that they provide like free services. I'm not sure if Dash has one, but I'm pretty sure Streamlit has one. That allows you to just host this website, like this service directly onto the internet. So if you want to say, hey, I think there's a cool pattern, I want to share that to the rest of the world, and the rest of the world doesn't know Python. Do I share this notebook directly? Well, that's one way to do it, but the thing is, a lot of the plotly plot will be dead after you share it or you export it. It's kind of a problematic thing to work with, and it's not a good idea to like export a lot of HTML file in a single directory. That's not the best way to demonstrate that, right? So they really turn this process into, okay, you can just write a Python file and create a simple demo, create your dashboard, and that's it. However, they are not a direct replacement for front-end framework. They're not designed to handle concurrency and lots of requests and user interaction, etc., etc. React and a lot of the front-end JavaScript framework, Angular, whatever, they existed for a reason because they're really the most flexible way to structure your website layout. I mean, Dash and Streamlit both support to some degree like how you can change the layout in the page, but they're not perfect. They're not designed for that. They're designed for a simple like demo. You're not supposed to host, okay, I have a great startup idea. I'm going to use Dash to build a website and create a new version of Amazon. It will not work because, well, Amazon handles millions, if not billions of requests per day. That's not what Dash is supposed to do. And do not try to run heavy application on Streamlit or Dash. They are slower comparing to a lot of the modern front-end and back-end frameworks. So That being said, let's see how we can turn this into a dash like app. So here is the code, exact code that I'm creating for the Dash app, but I'm not running it in Jupyter Notebook. Theoretically, it's possible to run it in Jupyter Notebook. I could just write this into a Python file here and use the terminal to run it. It's not a recommended process to do it. So I'm going to switch to a different tab. Okay, it's closed. Let me switch for a little bit and explain a little bit more what's happening. Okay. Let me see, where's my tab? Okay, I think this is the right one. Is my screen sharing working? Okay, hopefully this is working. So I'm using GitHub code spaces to okay. Hopefully it's not going to crash too bad. So, and in the same time, how many of you have successfully created a virtual environment in your local desktop or your environment of working for this week's assignment? Type +1 or thumbs if you have finished that, or please let us know if you have any questions with that. That's not the most intuitive thing you could ever do. Okay, no problem with it. Sounds great. So for this week's assignment, we strongly encourage you to work in the virtual environment because both Dash, Streamlit, Plotly are a little bit heavy in dependency, which means that if you did not install them in the right way, they might be very difficult to debug. They might rely on a very specific version of pandas or NumPy, and it may not be compatible with your local installation, and your dependency manager might not be able to successfully resolve these issues. So, wait, hold on. Source data bin activate. Hold on. Okay, so when you see this thing that in the beginning of your, before your command line, that means you're already in the virtual environment. And in my virtual environment, I'm going to install these things in the requirements.txt. You could also just run it for once and freeze it. What is happening? Okay. All right. So now, if I go to this Dash app, it's the same thing as in the Jupyter Notebook. I am loading the data set. Well, I uploaded the same file. Make sure your file is something you can read. Sorry. I am creating a new year column here. It's looking slightly different. And what Dash is doing is that it's interactively rendering the HTML content in its function. So these are just the HTML rendering things, sort of complicated. And here you can define different types of HTML styles and how to arrange them, etc., etc. And then each time when you're working on when you change something on the web page, we're going to call this update scatter function. It's going to, well, I set it so that I could adjust the year and the different columns that's there. So instead of just going through that, let's just see how this works in real life. Dash app. You can run the file, or if you prefer from the command line, enter this. By default, it's working in localhost 8050, I believe. Okay, it's taking a while. I don't know what's happening. Hello, why are you freezing? Okay, because I'm using code spaces, so it will create a kind of a dummy, a fake like a different URL for me. But if you run this on local computer, what you need to do is run like localhost 8050. Forget about the airflow. It doesn't work because I'm working completely remotely. This is not my local working environment. But if you're running this on your local desktop, you should type into your browser localhost 8050 and access that. You could also change the port if your localhost 8050 is occupied for whatever reason. You could also choose to expose this thing to the public internet. Disclaimer, this may risk your computer getting hacked because you're creating an endpoint where your computer is taking information from outside that's not encrypted or that's directly running this Dash app. I don't think there's anything wrong with it because there's nothing that could ingest into your local computer. But anyway, now this is what the Dash app is setting up. It's going to, okay, I can select the range and already filter the data so that it's only going to create 500 or so data points in the plot. And I could select whatever I want on the x-axis. Okay, and I'm plotting x-axis against x-axis. It's always going to be like a straight line. I could plot it against the plot. I could also plot it against other things. Okay, sales volume and so on and so forth, and mix and match that. Now I can run my visualization much better than before. Of course, this is still kind of a crappily made diagram, and it's imperfect. There's a lot of rooms I could improve. For example, what if I want, some of the patterns I might be able to observe some of the pattern if I zoom in or zoom out better. So let's try it. Add zoom in, zoom out. I don't want to box select anymore. But feel free to play with it. So this is something that I'm not sure if I could extract any insights from, but this could be someone's full-time job creating different dashboards and different trying to combine multiple different data sets and trying to show the business owner, okay, this is your business trends. This is the stock price. This is your, maybe this is what the data telling you what you should do. There's a lot of rooms you could play around with it. So this is a simple Dash application. And if you change the configuration of this file, you could try to expose this website onto a public URL, which means that other people could also see and work with exact same page as you're seeing here. That is a different story we're not covering today, but feel free to dive into Dash or Streamlit's documentations for that. I think Streamlit has a community cloud that allows you to just host the service there. Yes, you could just upload it there and upload. I think if you upload or just connect it with your GitHub repo, and Streamlit will be able to host this service for you. This is apparently a much better made visualization dashboard we have. Okay, so I think that's most of the materials I have for the day. Thanks for coming. Feel free to let me know if you have any questions. And yeah, feel free to play around the data you have. Now you have a complete set of skills from basic Python to pandas for data visualization, cleaning, and transformation. You have now also learned the tools to kind of host it on the public cloud, even though it's kind of a messy mess to do it with HTML rendering. I think there's still some bugs in my code here in the drop-down line here, and we'll see. But yeah, that's basically how things go. Right. I think that's all for today's materials. Feel free to let me know if you have any questions. And yeah, have fun with your assignments.
Thank you.
Yeah,